a nonprofit with the mission to ensure the sustainability of public lands and of the plant, animal, and the human communities that depend on them. I've been doing this for over 20 years in the nonprofit sector, and for 23 years before that, I was in leadership positions in the U.S. Forest Service. I got interested in biochar in 2007. It seemed to be right at the intersection of so many areas in which I was working. I got very excited about it, but realized that there was no central clearinghouse or source of information in the United States. And so I started the U.S. Biochar Initiative and was director of that for 9 years. So I am deeply immersed in biochar, all things biochar, and in particular the sustainability of biochar. One of the reasons that I got involved in biochar was that I could see that although it was an incredibly good idea and was basically mimicking nature, which is always providing the best solutions, that there was also the opportunity or the potential for overuse, abuse, inappropriate use, inappropriate feedstocks, a lot of things that could result in some very serious damage to soil and also damage to the biochar industry. If we weren't doing it right, supporting the triple bottom line, then we were really setting things up to give biochar a very bad name. So my emphasis has been on education, on the sustainable production and use of biochar. So with that, just walk you through some of the key issues. I will tell you that there is a set of sustainability guidelines that myself and another individual, experienced professional, developed. That's available on the U.S. Biochar Initiative website. And I'll provide that in the chat after my presentation. So building a sustainable biochar industry, and that means that we need to understand and support the socioeconomic and the ecological imperatives associated with that. So what's biochar? Well, it's charcoal with a purpose, and the bio comes from the fact that we try to repopulate the char with biology and nutrients, and that we also try to protect biology from heavy metals and toxins when we use biochar as a filtration system. You can see by the photograph, the surface area of biochar is absolutely amazing. And you can have thousands of square yards of meters, essentially, of surface area in just 1 cubic centimeter of biochar. And the biochar is bioreactive, chemically reactive surface that is reason it can attract and hold nutrients. It has a negative cation exchange capacity that's very high, depending on how it's made. I'll get into that in a minute. But that with water and nutrients being positively charged, attracted to those surfaces. So what is sustainability? Basically, it's benefiting from the use of resources in a way that does not preclude their use and enjoyment by future generations of all species. That's plant, animal, humans. And so we need to look across the spectrum. We look at the triple bottom line. That's the economy, our economic profitability when we're considering an industry, but also we have to look at environmental protection. How do we protect those resources that keep feeding our industry? And social equity. How do we ensure that people are engaged and supportive and benefiting from what it is that we're providing? So the elements that are involved in biochar, of course, are the feedstocks, the production technologies that we choose to use, and then the products in the markets. What are we actually producing, and where are we supplying those? All biochar is not created equally. Biochar can be very different based on its feedstock, the technology. That would be the degree of limitation of oxygen. A limited oxygen environment is called pyrolysis. full-on open burning is combustion, and the gasification lies in the middle. And depending on the temperature and the time in residence, the char can have a different quality or characteristic, and that can be by its pore arrangement, and it can be by its rest in its cation exchange capacity, action with water, ability to absorb water. So there's many different nuances of biochar and its characteristics, and you can actually create biochar specifically for specific purposes. So where are we getting our feedstocks? And this is a fairly short presentation. I was asked to just take 15 minutes, so I'm going to go a little more quickly so I get it in on. So building a sustainable biochar industry based on our biomass feedstocks. Richard just went over a number of those feedstocks, and I'd like to add a look at those same feedstocks through a sustainability lens. Biomass. According to us humans, a biomass is any carbon-based material which, when sufficiently dry, can be thermally converted to energy and other byproducts. Very good. But according to nature, biomass is a complex structure of mass and nutrients, regulating moisture and temperature, providing shelter, food, habitat, and carbon sequestration. I'm specifically talking here about, or more specifically talking about forest biomass, waste, theoretically waste, but leaving by a certain amount of biomass on the forest floor or in the agricultural fields is absolutely essential to forest health, to preventing erosion, to creating the habitat that's needed for microbes and mycelia, as well as larger animals. And so when we're looking at these three aspects, when we look at energy and what's the situation, well, demand continues to rise for energy. We have a declining availability of and desire for cheap fossil fuels, but we're not necessarily declining at all in their use, unfortunately. There's increasing pressure for domestic and renewable energy, but that also comes with a cost energetically and material-wise. Increasing demand for biomass energy and increasing demand for on-farm renewable fuels. As far as the productivity side, we see high quality for soil for rising food needs, and truly we need to be very focused on this as many global experts are predicting significant famine across the globe. So the idea that we can not take care of the soil is not feasible. Climate change mitigation, we need to ameliorate all the toxins in the environment, in the water, soil, air. There's rising transportation costs, which are affecting affordable and adequate distribution, and then declining forest health, catastrophic wildfires, and also the hurricanes and tornadoes and other natural disasters that rising in number and intensity. All of these things I'm discussing are affecting the biochar industry, even just the biomass industry. And then there's nature. We have to have the habitat for plants and wildlife. We have to maintain enough biomass in this cycle so that we have nutrient cycling. Biomass also helps with moisture and temperature regulation, very important for regeneration. Erosion protection, that's why the large push in agriculture to move to no-till so that we stop exposing the soil to wind and rain erosion, where we can lose up to an inch a year in topsoil. And then also carbon sequestration to help us deal with climate change. So those are that's the framework in which we're operating. So when you have biomass, you have renewability, availability, accessibility, and demand. It really puts a high requirement on intelligent use and sharing of those biomass resources. So to maximize sustainability, we want to try to localize and balance our use. And by localize, that means not shipping in biomass from distant places because of the transportation footprint. But also we want to balance that we make sure that all the necessary functions of biomass are being met, as well as our ability to use the excess We also want to support climate and ecosystem services. Um, Ecosystem services are those things that nature does for free for us that we can't readily replicate. That's like absorb CO2, produce oxygen, um, maintain soil stability and soil health, etc. And then we also need to employ a skilled workforce, full aspect of this. So when we look at products and markets in a sustainable biochar industry, that too has some requirements. We need to identify as many uses and product lines as possible. Right now, there's 54 known uses of biochar. We need to educate consumers on those uses and that it has demonstrable value, not that it's just a cool idea and and meets some of the things that we claim it does. We need The industry needs to have quality control through testing standards and certifications because we have to make sure that what we are producing and selling on the market really does what it says it's going to do. And that is not only through the quality control, but also through the science and data that backs what we're claiming this material will do. Its performance. So here's an interesting slide from Kathleen Draper and the Ithaca Institute, and it's looking at the current state of biochar markets. And the coding, it's not an abundantly clear slide, but the coding, when it's all green, that means that the represents a high or immediate value, and the more gray, dark gray that it has in the scale, the lower that value and immediacy. So in agriculture, you can see there's a very high volume available. The value is fairly low. Readiness is quite high. So this is I won't go through each of these, but we can see here the many different markets already available for biochar, and that is with gardeners, remediation, and filtration. And I would point out that this is really a booming market right now. We are finding that using biochar in management of stormwater runoff in city situations, that we can pick up about 90% of the PCBs, very persistent, nasty chemical. We can pull that out of the stormwater with the biochar. The livestock feed, this again is another emerging and exciting field in that livestock love biochar. Chickens, poultry, ruminants, that is the animals with four stomachs like cattle and sheep. The biochar helps reduce methane emissions from cattle when they ingest the biochar, just 1% volume by 1% by volume of their feed. Biochar, they can reduce methane outputs by cattle by 50%. It's also very healthy for them, and it charges the biochar, which makes wonderful fertilizer. Building materials, in packaging and materials, 3D printing, fuel cells, carbon offsets. Carbon offset market is very important to be better developed to make biochar production more profitable and economical, as well as more widespread. So when we're looking at the production piece, planet people, we need to have economically accessible markets that meet the needs that we find locally and regionally. And we need to improve environmental conditions while we're producing the biochar, and we can do that. And then again, transparency and quality solutions. So production technologies. This is a very popular slide just showing the basics of biochar production. The feedstocks are removed from their natural setting and put into a pyrolysis type of unit, a gasification unit, etc. 50% of that carbon is retained, as Doug mentioned. That's returned to the soil as biochar, or again as remediation tool. The other products that can come from biochar, syngas, wood vinegar, biodiesel, or bio oil, and the syngas. The syngas doesn't have as high BTUs as natural gas, but it can still be used to drive turbines and produce energy. Bio oil, we don't recommend upgrading that to biodiesel because the energy inputs to do that pretty much negates the carbon savings that you would be accruing. Bio oil can be used as a bunker fuel for shipping. So there are uses for that crude type of oil. And wood vinegar, of course, is another byproduct, which is very intriguing. Wood vinegar at full strength is a pesticide and herbicide. When it is diluted, it can be a very effective herbicide, and when it's super diluted, it actually becomes a fertilizer. So, processes. Your production technologies need to be configured to handle local biomass by type and volume. It needs to be built of regionally, nationally sourced recyclable materials. And hats off to Doug showing us how to build something at home from just about entirely recycled and recycled sourced material. It should be unitized, modular, repairable on site, scalable for future growth. You really want to avoid complex production systems that are dependent on specific parts that you may or may not have available. The system can be shut down if you cannot find specific parts. So keeping it simple and modular and unitized will be very helpful, not only for continuing operations, but also scalable for future growth. You want to use technologies that produce minimum waste, and that's whether it's gas or solids or liquids. You want to use the energy and all the co-products and the byproducts. And that could be a circular economy type of location with another industry. For instance, if you have a pyrolysis unit that is producing syngas and biochar, you can pull the syngas off, drive a turbine, and net meter back into the grid or use the electricity on site. You can take the heat from the pyrolysis unit. If you have a greenhouse located beside your unit, you can use the heat from the pyrolysis in the greenhouse and use the resultant biochar as a substrate for horticultural purposes in the greenhouse. So that's what we're looking for, that circular economy. Also, we want to ensure a small carbon footprint, and that's throughout the entire life cycle of the production. As well as the biomass. And we want to ensure that we have a high worker safety, correct ergonomics, that we follow fair labor standards. Because we're people. People are meant to be happy. Why should we create an industry where people are miserable to have to work there or hurt themselves or get sick? That's really the height of unsustainability. So with production, we want to look at revenues that exceed our operating costs, and we want them to be expandable with as near to zero waste as possible. They need to be energy efficient and have low emissions, and be a community asset, be something that the community is proud of and it contributes to the community's well-being and benefits. So in summary, we want to ensure that the biomass that we derive, the terrestrial biomass, that we obtain it and produce it in such a way that on a life cycle assessment basis, both feedstock, source, and point of use, that we preserve smallholder farms and watersheds. I will add a caveat to Richard's presentation about own biomass. That's mining the soil. If we're not replenishing that soil with non-chemical fertilizers, we are basically mining the soils and then sending those minerals, nutrients, and values elsewhere when we export them. So that's a consideration, particularly now when food food is so important and food production that we cannot take productive food or productive soil out of food production. So preserving smallholder farms and watersheds, we need to minimize the consumption of other natural resources, energy, and fairly share the surplus. We need to maintain or improve soil quality, reduce greenhouse gas emissions, protect habitats and native ecosystems for everything from mycelial to large mammals. We need to mimic nature and natural processes, and again, provide community benefits, jobs, and fair labor. And a sustainable industry also meets the triple bottom line metrics of economic profitability and environmental protection and social equity because it's geographically and decentralized and distributed. It's close to biomass sources and markets, minimizing transportation, supplies diverse markets and value-added products with no waste, participates in carbon markets and carbon trading programs. Production is carbon neutral and negative in the life cycle assessment. The product is quality assured through transparent processes. It's compatible with and supportive of ecosystem services. And again, community benefits, jobs, and fair labor. So, thank you. Any questions?